In problem 2, again, we check for that greatest common factor. 25x to the fourth y squared and 9 have no common factors. What we should realize then is that we only have two terms. When you have two terms, the chances are this is going to be a special binomial. And in particular, look for the difference of squares. To check for the difference of squares, we want to make sure each term is a perfect square, which they are. Meaning we can factor if we figure out the square roots. The square root of 25x to the fourth y is 5x squared y. That becomes the first term in each binomial. And the square root of 9 is 3. That's the second term in each binomial. We just put a plus and a minus between them both. And there's our final answer. We used difference of squares. For problem 3, we have what should be a fairly familiar problem. We look at a lot of these types of problems. And it's factoring a quadratic trinomial. We know that because the highest term is 2 and we have 3 terms. This will factor into binomial for x squared plus 2x minus 15. The factors of x squared are 1 and the 1 in front of the x squared are 1 and 1. The factors for 15 are 1 and 5, or I'm sorry, 1 and 15, and 3 and 5. 1 and 1 can be multiplied by, let's look at the 3 and 5 first. We get 3 and 5. And since this is a negative, then we want them to subtract to be 2, which works, giving us our middle term. So we get x, 3, 5. Since 2 is positive, we need the 5 to be positive and the 3 negative. And that is our final answer. Remember, you can always double check by multiplying through. And when we reduce, combining like terms, we find the same polynomial that we started with. Let's look at one more trinomial. In this trinomial, we have 5x squared plus 27x minus 18. Now there's a couple ways you can do this. You can look at the factors of 5 and 18 separately, or you can multiply 5 by 18, which gives us 90, and figure by negative 18, which gives us a negative 90, and figure out what multiplies. We want two numbers that multiply to give negative 90 and add to give 27. That's the algorithmic way to solve. I'm going to look at it a slightly different way. We know the factors of 5 are 1 and 5. The factors of 18 are 1 and 18, 2 and 9, and 3 and 6. Meaning we have to have factors 1 and 5. Let's try 3 and 6 first. We do 1 times 3. I'll flip this just to show you. 1 times 6, 5 times 3. You get 6 and 15. And these numbers need to subtract to give us 27. But they don't. So let's flip them. 1 times 3, 5 times 6. You get 3 and 30. These numbers subtract to give 27, which is our middle term. So our numbers are 5x and 1x. That's the 5 and 1. 5 multiplies by 6, 1 by 3, with the positive on the 6. There's our final answer, which again, you can check if you want to by factoring through, and that should bring you to our original polynomial.